Why, hello! Solve the given system using the elementary row operations and matrices. So first off, we have to write that system as an augmented matrix. What's that augmented matrix going to be? Yeah. Good. And off to the side here, I'm writing our goal. You don't have to write the goal, but it makes a good visual aid. So remember, the goal would be 1s on the diagonal, 0s everywhere else, and these are just going to be numbers. We'll figure those out later. We're going to take this one slow. It'll probably take us right to the class time. But then we'll start to go a little bit faster with more examples. Is everyone ready? All right, here we go. So those elementary row operations are, if you will, the rules, but they don't really tell you how to do it. So remember that scene or those scenes from Pirates of the Caribbean? They're not rules, they're guidelines. Yes. So I'm about to provide for you some guidelines. These guidelines will always work. They may not be the easiest though. So here we go. The guidelines are only work with one column at a time. That would be your first guideline. So we're going to start with the leftmost column. Now, I can't obviously do this because you'll still see the 4 or the 5, but what I'm getting at is, starting the leftmost column, you want to make your 1 and then make your 0, just like in our goal. Starting the leftmost column, turn this 1, 1 entry into a 1, turn this 2, 1 entry into a 0. One more time? We need to make this 3 into a 1, and then when that's done, make this 1 into a 0. Well, subtracting 1 is not allowed. Yes. We can only use that to make the 1 and the 0. So let's talk about making the 1. You always want to try to make your 1 first. If we use the first elementary row operation, which says switch 2 rows, notice if we switch these 2 rows, will we get a 1 right here? Yeah, how nice! So we're just going to switch the first 2 rows. Since we're switching row 1 and row 2, then according to the notation, we'll say row 1, double arrow, row 2. The entire row switches, not just the left-hand side. So what does that make the new first row? $27, and then 3, 4, 5 is the second row. We are 1/4 done. Congratulations. But we're not done with the first column because it does not match our goal. So where this 3 is at, we need a 0. To make zeros, you want to use the third operation. To make zeros, use the third operation. Ute ekmek erozes, uzes. I can't finish. The third operation is just like the elimination method. This is 1x. This is 3x. What should we multiply the 1x by so that when we add it to 3x, no more x's? So what would you multiply 1 by? So when you add it to 3, you get 0, negative 3. So we're going to multiply the first row by negative 3. So negative 3 times row 1. We're going to add that result to row 2. That's going to make the new row 2. So one more time. This is like 1x, this is like 3x, just like what we had for elimination. We need opposite coefficients there, so when added together, the variable goes away. So we're going to use the negative 3. Correct, the whole entire first row. What I suggest is off to the side, write down what negative 3 times the first row looks like. So negative 3 times 1 is negative 3. Negative 3 times negative 5, positive 15. Negative 3 times 27, negative 81. Questions on those black numbers there? Okay. We're going to take these numbers, which are the second row, and add it to negative 3 times the first row, these black numbers. So 3 and negative 3 make 0. So this new entry is now a 0. 4 and 15 make 19. And 5 and negative 81 make negative 76. To top off this Sunday, write back your first row. 1, negative 5, 27. You might ask, well, didn't we just multiply the first row by negative 3? Yeah, we did. But by writing it off to the side, we saved ourselves the step of multiplying it by negative 3 and then dividing by negative 3 to get our 1 back. So that's why I'm saying just write those numbers off to the side. It'll save you 2 steps. Notice our first column is done. We got our 1, we got our 0. We now move on to the second column. And so according to those guidelines, make your 1 and then make your 0. So where this 19 is at, we need a 1. The elementary row operation that will make 1s, it's not always the best, but it will do it, is the second operation. So the third operation is what you pretty much have to use to make 0s. The second operation you can use to make 1s. Second operation says multiply a row by a non-zero number. So what should we multiply 19 by to make 1? 1 over 19. In other words, the reciprocal. So multiplying by reciprocals will make your 1s. So we're going to say 1/19, row 2, makes the new row 2. Does this affect row 1? No. So row 1, I'm just going to copy. What is 1/19 times the second row? So let's go one at a time. Class, 1/19 times 0. 0. That was good. Brains. 1/19 times 19. What? And 1/19 times negative 76. Negative 4. We are 3/4 done. But I have to get rid of my goal over there. I have to erase that because I'm running out of room. Goodbye. All right. Where that negative 5 is at, we need a 0. What operation will make 0s? third one. So this is literally negative 5y, positive 1y. So what should we multiply 1 by? So when we add it to negative 5, it makes 0. Positive 5. So we're going to say 5 times which row? Row 2, y. Well, what does row 2 have? It has the 1. 5 times row 2 plus row 1 makes the new row 1. So 5 times row 2. So 0. So 0. 5 times 1. 5 times negative 4. We're going to take these three numbers, which is 5 row 2, and add it to row 1. Is this okay? So 1 plus 0. Well, good. 5 and negative 5. 27 and negative 20. You guys learn so quick. 7. And does row 2 change? Nope. Hooray!
So the object of matrices is to be a certain design in the matrix.
Yes. So now that we have that design, we have 1x equals 7 and 1y equals negative 4. So 7, negative 4. Hooray! That only took 3 times as long as doing eliminations. Wait until we do 3 variables. You will need at least a whole sheet of paper for 3 variables. You want the 2? Awesome. You'll need 7 sheets of paper for 3 variables.